Hi guys. Okay, we're on part 2 now of our sine and cosine graphing videos. So the first thing I want to ask you is to identify which one is which here. One of these is cosine and one of these is sine. Which one's which? Well, one thing or one way you can think about it is from 0 here from the midline. The first thing this graph does is it kind of goes up, it increases, but the other graph starts out right away and decreases. Something even easier than that, notice that this first graph here contains the point 0, 0, but the second graph contains the ordered pair 0, 1. So when I plug in a 0, where do I get 0 as an output for sine or cosine? Well, of course, that's going to be sine of x. And the other one, therefore, is cosine. When I plug in a 0, I get 1 as the cosine's output. Okay. Main thing I want to focus on in this video is how to find these important values, and again, I know that Stogner calls them key points. I also believe that your textbook calls them key points, although they could actually call them important values because these guided notes are based off of the book that we never use. Okay, first thing you need to do is figure out where the important values are. They are the tops, they are the bottoms, and they are every x-intercept. If you go to your graph, you've got one right here, one right here, one right here, another, and another. Yes, there's an infinite number more, but at this point we have reached a full period. We'll simply repeat ourselves. So how many key points are there for sine? There are 5. Seems to happen every every 2 pi, it repeats. And if you look at cosine, it goes the same way. We start at the top, but then we have an x-intercept, we have a minimum value, another x-intercept, and a maximum value. So there are 5 of them. Well, how do we figure this out? Well, look closely where they occur. It happens at 0, and then again at pi over 2, and then at pi, and then 3 pi over 2, and then 2 pi. So it turns out it's occurring every pi over 2 radians. Change colors. Pi over 2 radians. Well, where exactly did pi over 2 come from? The idea is the way that you find your key points for every single sinusoid. You take your period and you divide it by 4. Okay, so our period in this graph, of course, is 2 pi, and 2 pi over 4 is pi over 2. So the key points, the important values, are going to occur every pi over 2 radians. Kind of nifty, huh? General equation for the sinusoidal function. They're written there. I won't read them for you, but I will help you fill out this table. This is invaluable, folks. You just need to know what the A and the B and the C and the D stand for. Once again, it should not be new. You should have been exposed to this in Math 3. I'm simply going over it, excuse me, with you now to help you out some. Absolute value of A is the amplitude. Again, the reason that we have the absolute value there, remember, is that the amplitude can never technically be positive, always has to be positive. It can never be negative. The amplitude. That also, remember, is how you get a vertical stretch or a compression. Maybe I can squeeze that in here. Vertical stretch or compression. Okay, next one. 2 pi over b. What is 2 pi over b? That is the period. There we go. That also tells you your horizontal stretches or compressions. So this is the horizontal stretch or compression. C over B. C over B is your phase shift. If you took academic math 3, you didn't really focus on the phase shift at all. Phase shifting can get very confusing for students, and it wasn't really necessary until you hit pre-cal anyway. If you took honors, though, you were exposed to it. The phase shift, of course, is your horizontal shift left or right, along with a horizontal stretch or compression possibly combined in with it. So this is like a horizontal shift with a horizontal stretch or compression. And again, listen to the audio. You probably can't read my nasty handwriting there. D is the easy one. That's the vertical shift. It's what moves it up or down. Vertical shift. One thing to remember about the vertical shift, though, it does change the midline. And so if you have a vertical shift on a function, remember that the amplitude will also be affected by this because the midline is being changed. Let's put it all together and do a few graphs here. You need to pretty much include everything. Make sure you always graph at least one function, at least one period for every function. So we're going to write everything down. We're going to find those key points. We're going to do the whole 9 yards here. Okay, y equals negative sine of x. Bingo. First thing that pops into your head, ooh, it's a reflection, right? Let's write that down. It's a reflection over the x-axis. Okay, so right there I've made a note of what I know it should look like right away. Let's see, what do you want to do next? Probably fill out some of the bottom parts, right? Yeah, save the graph for last, because we need the bottom pieces in order to do our graph. Amplitude, what's the amplitude? -1, yay! Don't put that negative on there. Period, let's see, period is 2 pi over b. There are no other numbers in here though, so it's 2 pi over 1, which is just 2 pi. Phase shift, again, there are no other values in this function. I don't have to worry about it. There is no c. B is just 1. There is no shifting occurring. Important values. Here's where the party starts. Okay, so you take your period, divide it by 4, right? So you have 2 pi over 4, which is pi over 2. So every pi over 2, we are going to have important values. And notice on the graph, I've actually gone ahead and labeled pi over 2. Okay, so remember, that means that I'm going to have, let me change my color here real quick. I'm going to have it at 0, pi over 2, pi, 3 pi over 2, and 2 pi. Those are going to be the 5 key points that I must graph. When I plug in 0 to the negative sign, what do I get? 0. Now again, some of you could be thinking about this as simply a reflection. If you want to take the original sine graph and just do a reflection, that's great. You know, from here it would normally go up, and at pi over 2 you'd be at 1, but with a reflection, pi over 2 is down at -1. So it's actually down right there. No problem. I have no issues with that whatsoever. Okay, then pi, we're back on the axis. 3 pi over 2, 1, 2, 3 up there. And then I'm back down, see 1, 2, 3, right there. Oops. There we go. So that is the absolute minimum that you have to graph. Obviously that looks a little bit silly. It's never a bad idea to go ahead and plot at least until you pretty much run out of graph paper. 1, 2, 3, right back there. There we go. So, woohoo, wow, that first one was terrible. What on earth? Oh well, it gets the point across though. So there we go. Okay, to keep this video from running forever ever, I'm going to speed things along a little bit, and again I can just pass around the final answer key and let you folks check it in class. This one right here, this is a vertical stretch by 2. And so you're going to take your normal standard cosine graph and just stretch it up. You're going to pull it all the way. This time the amplitude will be up at 2 and or down at -2. 4, 5, and 6 are very similar to one another, and I think I'm going to pick number 5 just because, you know, for whatever reason students see fractions and they freak out. Okay, so the first thing I want you to do is think about what this is. You might think it is a horizontal compression, But again, be careful. The 1/2 is inside with the x. It is the opposite of what you would think. This is a horizontal stretch by a factor of 2/1. Horizontal stretch by a factor of 2. Okay? So when I do this, I'm basically going to take my normal graph, pick it up on each end, and stretch to the left and right. So it's going to be flatter than, oh, excuse me, not flatter rather, but it's going to, the period is going to stretch out. It's going to appear to have been flattened. It's not truly flattened in the sense that it still has an amplitude of 1. Let me keep going. I'll show you. I don't want to get ahead of myself here. Amplitude is 1. I just said that. Phase shift, still 0. I'm not adding and subtracting. See number 7, see number 8. That's where we get to worry about phase shifts. Not yet. Period. Period is 2 pi over b. Well, this time we actually have a value of b, right? We have 2 pi divided by 1/2. Well, 2 pi divided by 1/2, that's 4 pi. Important values. The important values appear at period divided by 4. So I'm going to take 4 pi divided by 4, and that means that this time the important values appear every pi units. So instead of it happening every pi over 2, it's going to happen at every pi. Folks, if you would like to, on the side of your graph, see how you have some white space in the margins on the left and the right? You could always make an XY chart if you need it. You can make X and then Y. Again, please do radians. Degrees are dumb. You would then think about, okay, I'm starting at 0, right? But instead of pi over 2, I'm just going to go pi, and then 2 pi, and then 3 pi, and then 4 pi. Oops. I unselected my pen there for a minute. Dang on it. Hold on. Oh, sugar. I lost my table. Oh well. But you get the idea at this point, folks. So if I plug in 0, of course, I get 1. Change my color here. Sorry about that. 0, you get 1. Okay. But then remember, my next key point is at pi. And so my x-intercept is now at pi. So, right there. That's pi. And then my next key point, which is now a minimum value, happens at 2 pi. So I got to count all the way over again. 1, 2, 3, 4, 5, 6. So right there, I'm going to be down at, oops, I went just a little too far there. Fat finger. Like that. Okay, then I keep on going. So I'm back at 3 pi now. 1, 2, 3, 4, 5, 6, right there. Ooh, that one was pretty good. Yeah, there we go. Getting better. Okay, and then I would go not at negative pi over 2, but over at negative pi. So there is my next one. I'll look at number 7 next. This one is a shift over to the right pi over 6. So let's see, this has a horizontal shift right pi over 6. Cool. Amplitude. Amplitude is 1. Phase shift, we just said it. You could do your C over B math if you would like. This one doesn't actually have a B. In fact, none of the ones on this particular sheet have both a B and a C, but it's a good habit to get into, that's true. So let me follow the actual formula. C over B is how I get my phase shift, just like 2 pi over B is how I find my period. Okay, it's just a formula. So the value of C here is pi over 6. Pi over 6. The value of B is a 1. And pi over 6 divided by 1, of course, is just pi over 6. So there's my phase shift, pi over 6. Period, again, you've got 2 pi over b, but the value of b is just 1, so 2 pi, we're good. And then important values, here we go again. Same deal, folks. You take your period, divide it by 4, and that tells you. So it is every pi over 2. Where my important values are going to take place. Now, one thing to think about here, this is a little bit weird. We know that this time it has been shifted to the right pi over 6. So my very first point is not at 0, 0. My very first point is actually right there at pi over 6, comma, 0. So that is actually my starting place. Start. So even though the important values happen every pi over 6, every pi over 2, you can't think of it as at pi over 2, pi, 3 pi over 2, 2 pi, because we've shifted it over. So what you might want to think of down here with the important values, instead of every pi over 2, you might want to think of it as every 3 pi over 6. Because now you can count it out. See what I'm saying? So like from your starting point, go over 3 pi over 6. Well, that's 1 pi over 6 over, hold on, let me find my laser pointer here. There you go. That's 1 pi over 6 over right there. That's 2 pi over 6 over right there. That right there would be 3 pi over 6 over to the right. So when I move that far over, I would have a maximum value. That's what comes next when I'm doing sine. And then I would move 3 pi over 6 over again, and I'd be back on the x-axis. Goodness gracious, what on earth was that? Ugh. That's better. Okay, then I would move another 1, 2, 3 pi over 6 to be down at my minimum value. And then I would move over another 1, 2, 3 pi over 6 to be back there. 1, 2, 3 pi over 6. Okay. Be careful right here. Remember, you're starting from your starting point, so you go over 1, 2, 3. You'll be right there. And then you go over another, etc. Okay, so there's my function. I think that just about does it. Again, I will have a complete answer key. Also, don't forget, folks, you can use your graphing calculator to check your work. It is important to know how to do these by hand, but you're also going to need to know how to use the calculator, and as we progress with the course, we will start using the calculator a little bit more. So, thanks for watching.